Welcome in to another new AMP podcast. I'm your host, Ben Dubose, news editor with the AMP publications team. Today, we're going to be talking about why welding and welding quality in particular is so critical to many of our association members and to the broader mission of corrosion protection and prevention. To do that, joining me on today's episode is Jason Becker, a highly experienced welder and fabricator with 25 years of hands-on experience in the welding industry. Under the American Welding Society, or AWS, Jason is a certified welding inspector, certified welding educator, and a certified welder performance qualifier. In addition to his extensive welding experience, Jason is a Marine Corps veteran and he holds a bachelor's degree in construction management. He currently works as a full-time welding consultant and is dedicated to helping, educating, and inspiring the next generation of welders through his own podcast called Arc Junkies. Jason, thanks for taking the time to join us today. How are you?
I'm doing great. Thanks for having me on, Ben.
Yeah, absolutely. And I think a good place to launch our discussion would just be to explain the significance of welding and, in particular, welding quality to a number of industries, but most notably corrosion control and what we do here at the Association for Materials Protection and Performance. How significant is weld quality? What constitutes a high quality weld? And what are the implications of subpar welds if it isn't done well?
Well, weld quality is paramount. I mean, if you think about everything that you interact with on a daily basis, it's welded or welding has touched that at some point, whether it's manufacturing, the automobile you're driving in, the bridge you go across to work, the building you enter. And weld quality matters because we need these welds to be able to withstand the intended load, whether that's structural steel I-beams, the frame on your vehicle, pretty much anything, like I said, anything we interact with on a daily basis. So if we have poor quality welds, things start falling apart and people start having a really bad day when steel structures start falling apart or automobiles or trailers start coming apart at high rates of speed. So weld quality is just as important to, the manufacturing or the assembling of these items as the items themselves.
So when we talk about welding processes and the impact on quality, what are some of the various techniques that are out there and how do each of those processes ultimately influence the final quality?
Primarily, we use four main sources of welding. So we have shielded metal arc welding, gas metal arc welding, gas tungsten arc welding, and flux core arc welding. Now, there's several other processes, but those are the four that are primarily used. Each one has its own place. Each one has its own purpose. So we could use shielded metal arc welding, more commonly referred to as stick welding, for a lot of the stuff that we do outside because it's going to deal with, dirtier environments like working outdoors. It's going to be able to withstand the wind loads, and it's going to make a sound quality weld. It's also going to produce something known as a low hydrogen weld, depending on the electrode that you use. But then we have things like gas metal arc welding, which more commonly referred to as MIG welding. We're going to use that for more high production, because it uses a shielding gas. That's primarily going to be utilized indoors. So think of a shop or a warehouse or a manufacturing facility or robotic applications. Okay. And then we also have gas tungsten arc welding. So depending on, the application that we're doing for that, a lot of times gas tungsten arc welding is used for aesthetics where things need to look very clean. They need to look very shiny. So a lot of times that process is going to be used in chemical plants, pharmaceutical plants, food grade things, because a lot, we're using stainless steels, we're using aluminum, things of that nature. And then flux core arc welding is going to be like a faster process that we would use outdoors. It's going to be able to withstand, the dirtier elements, higher rates of deposition, so we can weld a lot faster. So a lot of companies are actually switching to flux core versus stick welding out in the field just because we can do a lot more welding, get the same quality of weld, and we can do it at a much faster pace.
So let's talk about the different materials and substrates that are out there, because certainly different metals are going to require different approaches to welding. And so when we're talking about welding various materials, steel, aluminum, stainless steel, what are some of the challenges and best practices? What are the criteria that people should be keeping in mind as they look at not only the welding process, but trying to then tailor the process to a certain material or substrate?
Most of your steel, stainless, aluminums, they can be welded with any of the processes I mentioned other than flux core. You're not going to aluminum weld flux core, but it just depends on the application for that material. So as I mentioned earlier, if we're doing structural steel, I could use any one of those processes to fabricate the initial components. It's just going to depend on how fast I need to get it done, the location that the work is going to be performed. Very similar with stainless steel. A lot of times, like I mentioned earlier, that's going to be done with the TIG welding process, just because it's a lot cleaner. We can control a lot of the variables. It's typically done indoors for the most part. And then aluminum, it depends on if we're talking about a piping system or are we talking about a trailer or a truck, like a box truck or anything like that. Anything that's made out of aluminum, and what the weld quality actually needs to look like. Is this going to be something visible to everybody? We might want to use the TIG welding process. If it's done for high production, we just got to get it out the door. We might be able to switch over to a MIG welding process and run that through either a push-pull gun or a spool gun or a robotic application.
So let's talk about inspection techniques, because I know for our audience at AMP, one big concern when it comes to corrosion prevention and other concepts that would be of direct relevance to our audience is whether the welding process went as specified. So, what are the tools and methods available to inspect welds for potential defects? How do you ensure that these welding processes did go according to spec and that they meet the industry standards and the various safety requirements?
So that's where your certified welding inspectors are going to come in. Most inspectors are certified through the American Welding Society. However, some companies can certify or designate through their own practices and their quality assurance manuals. They can designate individuals to perform the inspections. There's a lot of different inspection techniques, and it usually depends on the end use of that product or the type of material. So, a lot of your piping and things like that, anything for petroleum, chemical plants, a lot of that stuff they can do on-site X-ray. They can run eddy current. They can do ultrasonic testing where they come out there very similar to like when a doctor is performing an ultrasonic test on an individual. It's very similar to that, except for we're going to do it on different materials. So those are some of the more deeper, if I need to look subsurface, I'm going to use an X-ray or ultrasonic testing. But if I need to look on top of the material, I can use like a dye penetrant kit, or I can use a mag particle setup where you actually dust fine metal particles onto the material. Now, this has to be a ferrous material, meaning it's magnetic, but you can put this fine powdered red dust on top of it, and you can run what's called a magnetic yoke across that, and it'll show any surface imperfections like cracks, porosity, undercut, lack of fusion, things like that you really can't see with the naked eye. It just helps bring that out. Same thing with the dye penetrant testing that can be performed in a lab, or it can be performed out in the field. What a lot of inspectors typically use for structural applications like bridges and buildings and going out on site for different structural setups, they're going to do a lot of visual testing, and then they have a handful of measuring tools that they'll use, like a VWAC gauge, which is a visual weld acceptance criteria gauge, or a bridge cam gauge. It really depends on what type of weld that they have to inspect. I typically carry around a bridge cam gauge, which will show weld reinforcement. I can measure the size of a fillet weld. So if something's spec'd out on a print and it says it has to be a 5/16 fillet weld, I can go out there and actually measure that and ensure that the weld is not oversized or it's not undersized. So it just depends on, the type of material, the intended use. And a lot of times engineering, they're going to put inside the blueprints when the fabricators weld everything up, they're also going to have inspection hold points so that these things are getting inspected while they're in process, as well as once the job is completed.
We talked about industry standards earlier and the importance of meeting them, meeting the various safety requirements. Obviously, it's important to adhere to the codes and standards that are out there. I guess, first off, what resources are available to people that want to, I suppose, learn more about the specifics of those standards, and how important are those generally to overall weld quality and the success of a given project?
I would say the first step would be to get in touch with your local AWS chapter. So the American Welding Society, you can become a member. Students can become members for free, and then they also have professional memberships as well as corporate accounts and school memberships. But that'd be one way to start, getting a hold of some of the different resources that you can utilize. That's kind of what I did in my career. I had no idea about weld quality. I had no idea about the codes and standards that I, as a welder, was expected to perform to. until I started networking with my local AWS members and, getting in touch with them and learning about the different codes and standards. So in addition to that, you can sign up and become a member of the American Institute of Steel Construction if structural is your thing, and there's a lot of benefits. It's a free membership. But you're also going to start networking with a lot of these people that have the same interest in your area. And you can start kind of picking their brain, learning what codes actually apply to the work that you're doing. A lot of the stuff that I did was held to the American Welding Society's D1.1, which is like the structural code book. You could also get involved with the American Petroleum Institute. So API 1104 is another code for underground piping or anything petroleum piping related. And then we also have ASME Section 9, which you can get in, with that organization as well. And, they do a lot of pressure piping and steam tubes and boilers and, things of that nature.
So we've talked a lot on this episode about the keys to success and what resources are out there for people to complete a welding process appropriately. Let's go to the other extreme. Let's talk about some of the common pitfalls and defects that you encounter when you're looking at these welds. Are there any common themes? What are the causes behind them? And what are some of the best strategies to potentially rectify them or prevent them altogether? Ultimately, we want to improve weld quality. We want to make these more reliable. So, are there any common themes or lessons learned from the defects and the pitfalls that you see out in the field?
Yes. So within the code, there are certain welding discontinuities that are considered acceptable. So depending on which code you're working to and the intended use of the item that's getting inspected, you might be able to have a certain amount of porosity. You can have a certain amount of undercut. That doesn't necessarily mean it's a defect. Once that discontinuity adds up to a certain level, then it becomes a defect. Once it's a defect, it can be considered rejectable. So all welding defects are discontinuities, but not all discontinuities are welding defects. Some of the more common ones that I've seen in my time out in the field would be porosity. So like I said, depending on which code you're working to, there could be an allowable amount of porosity. That's going to be up to the inspector to come out and interpret that. But as a welder myself, I thought for many years that no porosity was acceptable. So if I made a weld and it had porosity, I would go ahead and cut that weld back out, remove it, re-prep the weld joint, and re-weld it so it was up to par to my standards before saying, hey, I'm ready for the inspector to come over here and check my work. And a lot of times these defects can be fixed or, alleviated completely just by, paying attention to some of the fundamentals of welding. Contact tip to work distance or arc length, my work angle, my travel speed, things of that nature. Another common discontinuity, which actually becomes a defect, is over welding something or excessive welding reinforcement. And that's because it puts additional stress and strain on that weld joint. So a lot of people think if I put, if the weld calls out for, a 1/4 inch fillet weld and I put on, a 3/8 fillet weld, bigger is better, right? Well, not necessarily. I'm putting undue stress because what heat does is heat moves metal. You're actually putting that material under additional stress. So that weld could eventually crack or break once it becomes in service. The weld size that's dictated on the blueprints is sized that way for a specific reason. It's meant to hold that intended load, or, actually some welds are actually designed to fail at a specific point, depending on what the application is. But if I oversize that weld can't perform the job that it's supposed to, or like I said, I can put undue stress on there. So that's another thing. Overlap is a huge one, and that's just caused by improper work angle. That also could cause issues when it comes to coating, because of a lot of your coatings, they're going to be more viscous or a thicker viscosity or like surface tension than actual water. So if I, have a weld with overlap on it and the paint covers it up, well, if that part cracks, which is what overlap's going to cause in the long run, well, now that coating separates. Once that coating separates, now I'm blocking, or I'm opening up an area for water entrapment. Once water entrapment gets in there, the piece can start oxidizing. Once it oxidizes, then it starts to fail.
Let's talk about things on an individual project level. For someone listening that's got their own project, maybe it's large, maybe it's small, maybe it's something they're working on themselves. what are some general tips and strategies that they should consider to enhance their own processes and ultimately improve that quality?
As far as welding quality,
Yeah.
I would say whether you're self-performing the work or whether you're contracting the work out, make sure the individual that's performing the work is qualified to do that. There's a lot of people in, I'm sure, several industries that they have that fake it till you make it mentality,
Hmm.
and you don't really find out that that's their level of workmanship until after the job's completed. So I always recommend people to get formal training. A lot of people try to learn on a job site, but then again, you kind of fall to the situation of you're only going to be able to be trained by the people that you have at your disposal. And if that person wasn't properly trained, they learned the wrong way. They're going to pass that same bad information off to you, and it becomes a vicious cycle. So if you're self-performing the work, make sure you have the training to do that. Definitely do your research. And if you're hiring that out, make sure you're vetting your subcontractors or your employees to be able to do that work.
Calling all coating and corrosion experts. Join us at the AMP Central Conference in Albuquerque, New Mexico from September 11th through the 13th. Network with industry leaders and discuss topics directly impacting the central region of the United States. Don't miss this opportunity. View the technical lineup and register at amp.org/events/central-conference.
We've referenced associations a few times. Obviously, this is an AMP podcast. You're certified under AWS. What are the ways that these associations can and should work together? What are some of the things that an AMP member listening to this podcast might can do if they want to put a greater focus and spotlight on weld quality and making sure that we take some of these steps that you've been outlining?
Well, I think at the end of the day, all these different organizations should work together because we're inspecting things to a high quality. Quality matters, whether it's, coatings quality or weld quality. I mean, these things are kind of intertwined. If I have bad weld quality, you're not going to be able to coat that adequately. So, I mean, these different organizations, they should be working together hand in hand. A lot of these codes should align. A lot of these codes do align. It's really going to come down to what the engineer recommends or what they spec out in their set of blueprints. I'm sorry, can you repeat the question?
Oh, I was just saying, what are the ways that A, they should work together, the associations that is, and then two, things on an individual level that an AMP member listening to this podcast might want to do. I suppose it's just learning more and getting more involved, but just anything that they can do to enhance the mission on an individual level.
Yeah, I'd say on an individual level, you could get more involved with these different organizations. So if you're a project manager, um, or superintendent on some of these job sites, or even the engineer, you should be kind of taking a deep dive into some of this stuff. You have to have a better understanding of how these things intertwine, how one works with the other. So some of the things you can do is, like I mentioned before, going to an AWS section meeting. If you're an AMP member, it's pretty much open to the public, so you can work with some of the other welding inspectors, because some of the inspectors, they're actually dual certified. They hold certifications with multiple organizations, whether it's AMP and AWS, along with they could have ASME certifications. There's a lot of synergy between that. I mean, anytime we talk about buildings or coatings or construction or manufacturing, a lot of these codes are incorporated. So the more you can learn about each individual facet, I think the better you're going to be off in your career.
So let's talk about your story before we wrap up, because beyond the work you do as a consultant, you've got your own podcast, Arc Junkies. You go the extra mile on a number of fronts. Why is this something that you're so passionate about beyond just simply doing it for financial reasons, for business? Obviously, this is something that with Arc Junkies you've taken to heart. You want to be a leader. Just tell our audience a little bit about your personal story and why it's something that you're so passionate about going the extra mile with this.
So I really didn't have a lot of resources when I was growing up when it comes to the field of welding. Like, I went to a vocational school, I learned how to weld, and that was pretty much it. And it wasn't 100%. So once I joined the Marine Corps, I was lucky enough to be a welder in the Marines. And when I got out in 2005, I found myself, looking for a job, and I got into structural steel ironwork. The great thing about welding is the more I learn about welding, the more I realize that I know absolutely nothing about welding. I mean, I went off and got all these different credentials. I went to school for a lot of this stuff, but no matter how much I learn, I can never know it all. It's kind of like, I guess, if anybody collected Pokemon, you got to catch them all. So the deeper I dive into this industry, the more I learn, and
Yeah.
the more I realize there's a vast amount to continue to learn. And so I kind of wanted to be a resource for a lot of the young welders because, as most people know, there is a huge shortage in the skills, or there's a huge skills gap right now. There's a big shortage in blue collar workers. So if I can do something, whether it's a podcast, I actually opened up my own welding school recently to train welders, to do weld consultations, weld certifications. If I can do my part, I'm just, trying to help shore up other people so that they can learn at a faster pace than, the 25 years that it's taken me to get where I'm at. If I can take the information that I've accumulated over the past 25 years and dump that out into, hour and a half segments on my podcast, or, bring a bunch of kids into my school and teach them how to weld and, why weld quality matters. That's a big one, because a lot of people are like, oh, it looks good for my house, or, that'll hold, or it's good enough for government work. You hear that all the time. I want to see welding become a form of craftsmanship again. When I learned, you take a lot of pride in your work. And I think a lot of that isn't being taught nowadays. And so I want to do my part to, like I said, help educate and inspire the next generation of welders and kind of advance them and allow them to avoid a lot of the same mistakes that I made when I was coming up through the ranks.
Let me follow up on skilled trades and the labor issue, because I think that's a really fascinating juxtaposition. We've been talking for the last 20 minutes or so largely about the importance of weld quality and people in the industry making sure that their welds are according to code, that are basically performing as intended. And education is a critical component, but we're also facing, and a lot of the projections say it's only going to accelerate in the coming years, this shortfall of craft workers. And so there's a delicate balance to be had. Sure, you want to focus on education. You want to make sure that people are aware of the standards and taking advantage of the resources that are out there to make sure that their work is up to par, that they're meeting the requisite quality for a given project. Yet at the same time, a lot of projects are only as good as the workers available. And that's something that's become a greater concern in recent years. And as mentioned, it's only projected to accelerate in the coming years, at least for the foreseeable future that I've heard. So, how do you balance, I suppose, this emphasis on education with also the importance of, I guess you'd call it outreach to a new community and bringing more people into the fold in terms of welding? Because ultimately, we can talk all day about the education initiatives, making more people aware, but on some level, a lot of it just comes down to how many people, skilled people that is, are available to complete these projects, right?
Yeah. So I think one thing people could do is, like, a lot of companies should work with their local tech schools, make sure their tech schools are teaching the
Mm.
students coming out of there what they need to know to enter industry. A lot of schools, they're still teaching the state mandated curriculum when it comes to these skilled trade things that, nobody in the industry is using, like oxy-fuel welding. I took that completely out of my curriculum when I was
Mm.
teaching at a college level because nobody was hiring for it. What I had the benefit of working for an accelerated training program. So what I did is I went out and spoke with people in industry. Hey, what are the skills, talents, and abilities you're looking for? And that's what I collected all that information from several different employers. I went back to my school and I made sure that that's what my curriculum was based off of, so that as I trained these students, they could enter directly into the workforce and kind of be leaps ahead of the other programs that are kind of held to that mandated curriculum. So one thing companies can do is, get involved with your local tech schools, go sit on an advisory board, donate supplies. A lot of these schools, if they do have a welding program, it's underfunded, so donate materials, donate time, donate your expertise. A lot of the instructors really aren't qualified to be teaching this stuff. So if you have welders at your shop, if you can turn them loose for a Friday and go down and work with the local tech school and improve weld quality, those students are going to want to come work for you when you get out. So now you've essentially created a pipeline. Everybody's screaming for welders and blue collar trades workers, but nobody wants to go seek them out. They want to put up an ad on Indeed or LinkedIn where the kids aren't even there. Go down to the local tech schools and start working with them on a one-on-one basis, or, like I said, provide materials, and you can start creating your own pipeline of, reliable employees that are skilled up to enter, the workforce.
I think that's great advice. Folks, that is Jason Becker, experienced welder and fabricator with 25 years of hands-on experience in welding. He now works as a full-time welding consultant and hosts his own podcast, which we've referenced a couple of times. Jason, before we let you go, for any of our listeners that want to get in touch with you, learn more about you, perhaps check out some of your podcast episodes, what resources do you have available that may be applicable to our listeners?
Yeah, people can find me on Spotify and Apple Podcasts and wherever else you get your podcasts under Arc Junkies Podcast. I'm also on YouTube as well, LinkedIn under Jason Becker, and then I'm going to be at the IEC conference coming up very soon, and I believe you guys are going to be out there as well.
IEC from November 8th through the 10th in Austin. Look forward to seeing you there. Jason, thanks so much for taking the time.
Bang, thanks you.
Absolutely. And that'll do it for this episode for us at AMP. If you want more resources on our end, you can go to ampp.org. That's amp.org, the website for the association. And of course, I'm going to throw out a plug to our publication websites as well, materialsperformance.com, coatingspromag.com, if you want resources from our AMP publications, Materials Performance Magazine or Coatings Pro Magazine. With the plugs complete, we will adjourn. For Jason Becker, I'm Ben Dubose. Thanks as always for listening, and please come back soon for another new AMP podcast.
Thank you, Ben.